All right, we're going to continue our discussion of how many digits should be in an answer, but this time we're going to do calculations with significant figures, okay? So it's one thing to be able to just look at a number and be able to determine how many significant figures it has, but it's another thing to do the calculations that we have to do in this class, and then at the end, give your answer with the correct number of significant figures, because there are rules and it is important. So again, here are the objectives. Pause the video if you really want to look closely. But we're going to get to it. So a couple of reminders. Remember all the certain digits and one uncertain digit, that last digit in the measurement, the one where you're like, I think, that's the one that's uncertain. Exception, when we count. So if I count 753 exams, all of those digits are significant, the 7, the 5, and the 3. There's no uncertainty when I counted, but when I measured, the last number, the number furthest to the right, is uncertain, but it is still significant. All right, so let's review. Remember, I told you the sort of little trick. So again, I look at the number. Is there a decimal point? No. So here's a hint. Begin where the decimal point would be. Over here. And start counting as soon as you get to a number that's not a 0. 1. Okay, so there's a decimal. So I start on the opposite side. I start over here. Skip any zeros until you get to a number that's not a 0. That's the 3, and then count. So I should see 3. There's a decimal. Start over here. Count all of them. There's a decimal. Start on this side. Skip, skip. Just 1. There's a decimal. Start on this side. Skip. Once I start counting, though, can't stop counting. 1, 2, 3, 4, 5. There's no decimal. This side. Start where the decimal point would be. 1, 2, 3. There's a decimal. Start on this side. That's not a 0. Start counting. Count everything. There's a decimal. Start on this side. That's not a 0. Count all of them. There's a decimal. Start on this side. That's not a 0. Count them all. No decimal. Start on this side. That's not a 0. Start counting. Count them all. Okay, so hopefully that little trick helps me. So you have to know the rounding rules. So if the digit to the right is 5 or greater, round up. So right here, 0.7553, I got to round it to 2 significant figures. Okay, this doesn't count that 0. So 1, 2. I look to the next digit to the right, that's a 5. That tells me to round up, should be this. Round this to 2 significant figures. Remember, this doesn't count. 1, 2, look here, 7 says round up. 0 does not count, still rounding to 2 significant figures. 1, 2, look here, that says round up. But when I round up a 9, right, it becomes a 0, so it kind of like transfers over, so it would be 80. So it's like rounding 79 up 1 to 80. If the digit to the right is less than 5, keep the digit the same. So round to 4 significant figures. So there's a decimal, we start here. 1, 2, 3, 4. Then I look here, oh, that's less than 5, so I'm going to keep this the same. Essentially, I'm rounding down, meaning I'm eliminating these digits. I don't do anything to this number. I leave it alone, though. Okay? 1, 0, 3, 4, rounded to 3 significant figures. So no decimal, so I start counting 1, 2. All right, so I need 3 significant figures. Okay, so I have to think about this a little bit, right? So I don't want to round over here. I do want to round on this side. So if I round 1, 0, 3, so this 4, because this would give me 3. So this 4 should become a 0. So is that right? So 1, 2, 3. Okay. It's a little confusing when there's not a decimal sometimes. This, I only want 1 significant figure. There's a decimal. Skip it, skip it. 2. Look here. Okay, I leave the 2 alone, and then I'm going to round down by getting rid of all of those. Like that. All right, answers cannot show more precision than the measurements. So when we add or subtract, first add or subtract the numbers. Just do that. Keep all the digits that are to the left of the decimal point. They all stay. Then we keep the fewest digits after the decimal point based on the measurements. So let's look here. So here's these numbers. I'm going to add them up here, right? Now, keep all the digits to the left of the decimal. So I'm going to keep the 40. Now looking over here, for the digits to the right of the decimal, look back at these measurements. Find the least number of digits after the decimal point. So I look after the decimal that had 2 digits, that had 1 digit, and that had 3 digits. So the lowest number of digits after the decimal point is 1. That's from here, the 12.1. So I have to round this answer, so there's only 1 digit after the decimal point. So that means I want this, but I look here, that 8, that tells me to round up, right? So it's going to be 40.2. Now when we multiply and divide, the answer cannot show more precision than the measurement still, but here's the rule. First you multiply or divide. Okay, well that's convenient. The rule is still just do the math first. Then you look for the least precise measurement. So look for the least number of significant figures. Decimal or not doesn't matter. The answer must have the same number of significant figures as that least precise one. All right, so here's math. So just do the math. Look at the measurements. Which one has the least number of significant figures? Well, this has a decimal. Start counting over here. That has 2. This has a decimal. Start counting over here. 1, 2, 3, 4, 5. Okay, so 6.0, it only has 2 significant figures. So that means my answer can only have 2 significant figures. So this has a decimal. Start 1, 2. Okay, so that tells me I gotta keep that 2, right? But everything else goes away. So it just is 920. All right, so let's practice. So the volume of a sample of isopropyl alcohol is 32.4 milliliters. The grams 25.42. Calculate density. Okay, so I did the math, right? Density is mass over volume. I did mass divided by volume, and I got a whole bunch of numbers in my calculator. It should be 3 significant figures. Why? Look at this measurement. That has 4. This measurement has 3. We divided, so the rule is it's based on the least number of significant figures. So there's our answer. So this 0 doesn't count as significant. 1, 2, 3. Look here. I round up. All right, so here's partial pressures. Calculate total pressure. So total pressure is sum of all the partial pressures. So I add them up, I get this. Now I added, right? So the rule for adding is I keep everything to the left of the decimal, and then I look after the decimal. What was the lowest number of significant figures? So 8.1 only has 1 digit after the decimal point, so the answer can only have 1 digit after the decimal point, so you have to round it appropriately. Notice number units, no naked numbers. All right, in class we do some practice with the blue kit, significant figures, really kind of cementing that in our heads. And there you have it. Those are calculations with significant figures. Remember, the rules are different whether you add or subtract. Adding and subtracting, it matters how many digits are after the decimal point. Multiplying and dividing, it matters how many total significant figures there are. And with both of them, it matters the least, okay, which one has the least. So I hope you learned something new today.